All right, welcome to today's class. In today's class, we'll be proving the mean effective pressure of an Otto cycle. We'll be proving the formula. So, of course, the course is internal combustion engine, like we all know. All right, so let's dive into it. Now, what we have on the board here is nothing but a PV diagram of an Otto cycle, whereby we have four basic processes. Now, the first process is process 1 to 2. In process 1 to 2, we have nothing but what? The reversible adiabatic process, otherwise known as the isentropic process. Also, from state 1 to 2, that is where we find what? The compression ratio, which is nothing but what? V1 all over V2. Next, we have the second process, which is what? Process 2 to 3. From process 2 to 3, we have what we call the no constant volume heat addition process. Of course, and still at this process, that is where we have what? The pressure ratio, which is nothing but what? P3 all over P2. Next, we have what? Process 3 to 4. From process 3 to 4, we have the what? We have the irreversible adiabatic process, the adiabatic expansion process, which is the same thing as what? Isentropic expansion. Lastly, we have process 4 to 1, which is what? Which is constant volume heat rejection process. Now, let's dive into the proving. Mean effective pressure is nothing but what? It's nothing but work done all over swept volume. Now, I will know that work done is nothing but what? CV into what? T3 minus T2, close bracket, minus CV into what? T4 minus T1. And the swept volume is nothing but what? Is nothing but what? The volume at the beginning of compression minus the volume at the end of compression. That is V1 minus V2. So, like I said, my mean effective pressure is equal to work done. All this is what I have as my mean effective pressure. Now, of course, first I'm going to be what? Bringing out the relation for work done and the relation for swept volume so that I can impute them in this formula. So let's do that right away. Now, like I said before, work done is nothing but what? It's nothing but heat supplied minus heat rejected. So I can denote this by QS, heat supplied, minus what? QR, which is heat rejected. Now, if you come to this diagram, the heat supplied is from what? Is from state 2 to state 3. And the heat rejected is from state 4 to state 1. And don't forget also, the heat supplied is at constant volume and the heat rejected is at constant volume. So my work done will be equal to CV, that is heat supplied at constant volume from state 2 to state 3. I have into the bracket of what? T3 minus T2, close bracket, minus CV. Heat is also rejected at constant volume. So we have CV there from state 4 to state 1, which is what? Which is T4 minus T1. I hope you understand this. So, of course, this is my relation for work done. I'm going to be bringing out my relation for swept volume. So let's do that. So my swept volume denoted by, I can just say this is work done. Now, this is what I have. Now, for swept volume, V subscript S, this will be equal to V1 minus what? V2. Like I said before, swept volume is nothing but what? The volume at the beginning of compression minus the volume at the end of compression. So let's proceed. Now, I can rewrite this V1 minus V2 as what? As V1 into the bracket of what? 1 minus what? V2 all over what? All over V1. Of course, if I clear this bracket by V1, I'm going to have what I have above here. So next, what do I do? We know that from ideal gas relations, we know that PV is equals to what? Is equals to RT. And if we say, for instance, we are considering state 1, I can say that this thing, I can rewrite this as what? As P1 V1 equals to RT1. I hope you are following. Now, I can make V1 the subject of the formula here in order to impute its value into this equation. So let's do that. So if I make V1 subject here, what do I do? I'm going to be dividing both sides by its coefficient. So if I divide this by P1, divide this by P1, what's going to happen? You realize that V1 will be equal to what? Will be equal to RT1 all over what? All over P1. So I hope you get what I just did there. So I'm going to be substituting this value in this equation. So let's do that. So my Vs, V subscript S, which is my square volume, will be equal to V1, which is what? RT1 all over what? All over P1 into what? Into 1 minus. Now, in the place of V2 all over V1, I have stated before that V1 all over V2 is nothing but compression ratio. And it means that if V1 all over V2 is compression ratio, it means that V2 all over V1 will be the inverse of compression ratio. So this will be what? 1 all over compression ratio. Close the bracket. So this is my relation for swept volume. So next, I'm going to be taking the LCM of what is inside this bracket. So Vs will be equal to RT1 all over P1 into what? Into the bracket of what? Compression ratio minus 1 all over what? All over compression ratio. So this is what I have. Now, of course, I can rewrite this by saying that V subscript S is equals to RT1 all over P1 compression ratio into the bracket of what? Compression ratio minus 1. So this is what I have. If you multiply through, you get what you have here. So let's proceed. Now from here you can see that we have gotten a relation for work done. Let's call this equation 1. And we have also gotten a relation for our swept volume. Let's call this equation 2. Now I'm going to be substituting equation 1 and equation 2 in our formula for mean effective pressure. So let's do that. So my mean effective pressure, which is equals to work done. What's my work done? My work done is equals to this. So in place of work done here, I'm going to be putting what I have here. So my work done is equals to CV into what? T3 minus T2, close bracket, minus CV into what? T4 minus T1, close bracket, all over my swept volume. Now my swept volume is nothing but what? This. So I'm going to be putting this here. I have RT1 all over what? P1 compression ratio into the bracket of what? Compression ratio minus 1. This is what I have. So next we are going to be what? We are going to be simplifying further. So I can rewrite this here as what? Mean effective pressure equal to what? Equal to, now here we have CV at this side and we have CV at this side. This is common, we can factor it out. So we have CV. Now I can further rewrite this by saying that what? Mean effective pressure is equal to CV into the bracket of T3 minus T2 minus the bracket of T4 minus T1, close bracket. This will be dividing, of course, RT1 all over what? P1 compression ratio to the bracket of what? Compression ratio minus 1. Now to change this to multiplication, of course, I'm going to be taking the inverse of this. So my mean effective pressure will be equal to CV all into the bracket of what? T3 minus T2, close bracket, minus T4 minus T1, close the bracket. This will be multiplied by P1 compression ratio all over what? All over RT1 into the bracket of what? Compression ratio minus 1. So this is what I have. So I can further rewrite this by saying my mean effective pressure is equal to CV all over R multiplied by P1 compression ratio all over the bracket of compression ratio minus 1. This will be what? This will be multiplying the bracket of what? T3 minus T2, close bracket, minus open bracket T4 minus T1, close bracket, all over T1. So what I have here, of course, is nothing but what I have here. I just rewrite it in another form. If you multiply back, you are going to get what is here. So next, we are going to be we are going to be looking for the values of temperature. We are going to be looking for the value for T3, a value for T2, and a value for T4. Now come back to this diagram. From state 1 to state 2, like I said before, we have the reversible adiabatic process. So for process 1 to 2, for process V1 all over what V2 all to the power of gamma minus 1 equal to what T2 all over what T1. Now, of course, we have stated before that V1 all over V2 is nothing but compression ratio. So I can rewrite this by saying that what compression ratio to the power of gamma minus 1 is equal to T2 all over T1. Now, if I make T2 the subject here, I will cross multiply, and then T2 will be equals to T1 multiplied by compression ratio to the power of gamma minus 1. So T2 will be equal to T1 compression ratio to the power of gamma minus 1. So this is my value for T2. Now let's proceed to the next state. We have state 2 to state 3. Now from state 2 to state 3, we have the what? The constant volume heat addition process. Now in this process, we have P3 all over P2 to be equal to what? T3 all over T2, because for this process we are having what? Constant volume. Now if you come back to this diagram, you will agree with me that from state 2 to state 3 is the what? Is the constant volume heat addition process, and this is where we also have what? The pressure ratio, which is what? P3 all over P2, and is denoted by what? By alpha. So I can rewrite this by saying alpha is equal to T3 all over what? All over T2. So this is what I have. Let me just rewrite this properly. So I have T3 all over what? All over T2. So we can further simplify by cross multiplying in order to get the value of T3. So let's do that. So from this place, I'm going to be cross multiplying this. If I cross multiply this, T3 will be equal to what? T3 will be equal to T2 alpha. Now, already I have my T2 to be equal to T1 compression ratio to the power of gamma minus 1. So I will, in place of T2 here, I'm going to be putting T1 compression ratio to the power of gamma minus 1. So this will be T3 will now be equal to what? T1 compression ratio to the power of gamma minus 1 multiplied by alpha. So this is what I have. So next, let's go for that to state. We'll be going for that to state 3 to 4. Now for state 3 to 4, we have the what? We have the reversible adiabatic expansion process. Okay, so and this is nothing but what? This is nothing but T3 all over what? All over T4 equal to what? V3, V4 rather, all over what? All over V3, all to the power of what? Gamma minus 1. Now we have established earlier from this diagram that V1 is equal to V4, because at state 4 to 1 we have what? We have the constant volume heat rejection process. So the volume at state 4 is the same as the volume at state 1. So V1 is equal to V4. Similarly for this state, we have V2 to be equal to V3 because the heat supplied is at constant volume from V2 to V3. So V1 being equals to V4 and V2 equals to V3, I can further substitute this V2 and V1 into this equation. And don't forget that also V1 all over what? All over V2 is equals to compression ratio. So if I substitute this, I'm going to having T3 all over T4 to be equals to what? The bracket of what? V1 all over V2. Yes, this is what I have. All into the bracket of what? Gamma minus 1. So this is equal to compression ratio to the power of gamma minus 1. Now, in order to make T4 the subject here, I can cross multiply. If I cross multiply, I'm going to be having T3 to be equal to T4 compression ratio to the power of gamma minus 1. Now, if I divide both sides by the coefficient of T4, I have gamma compression ratio to the power of gamma minus 1 here, compression ratio to the power of gamma minus 1 here, compression ratio to the power of gamma minus 1 will go with this, and I will be left with T4, which will be equal to T3 all over compression ratio to the power of gamma minus 1. So I hope you get that. So now we have established already that T3 is equal to T1 compression ratio to the power of gamma minus 1 multiplied by what? Alpha. So I'm going to be substituting this value of T3 in this equation. If I do that, I'm going to be having T4 to be equal to what? T3, which is what? T1 compression ratio to the power of gamma minus 1 multiplied by alpha multiplied by 1 all over what? Compression ratio to the power of gamma minus 1. Now from here, you will agree with me that compression ratio to the power of gamma minus 1 will cancel out compression ratio to the power of gamma minus 1. I will be left with T1 alpha. So my T4 will be equal to T1 alpha. So this is my value for T4, this is my value for T3, and this is my value for T2. So I will be substituting the value for T4, the value for T3, and the value for T2 into this equation. So let's do that. Substituting our values for temperature in this equation. So let's do that. So I have my mean effective pressure to be equal to what? To be equal to CV. This will be equal to CV into T3 minus T2 minus CV. Now, before we do this, before we do this, here is what I just rewrite up here. So now let's simplify this further. Of course, from here, you can see that we have CV here, and we also have CV here, which is common. We can factor that out. So if we do that, we are going to be having our mean effective pressure to be equal to what? Our mean effective pressure will be equal to CV into the bracket of what? T3 minus T2, close bracket, into the bracket of T4 minus, don't forget your minus, so we have minus into the bracket of T4 minus T1, close bracket. Now, of course, you know that what is here is still the same thing as divide by RT1 all over P1 compression ratio into compression ratio minus 1. Of course, you agree with me that what we have here is the same thing as what we have here. Now, in order to further simplify this, we can say that mean effective pressure is equal to what? CV into the bracket of what? Into the bracket of T3 minus T2, close bracket, minus the bracket of T4 minus T1, close bracket, multiply by P1R all over P1 compression ratio rather, all over RT1 into the bracket of what? Compression ratio minus 1. Compression ratio minus 1 will be here. Compression ratio minus 1. So this is what I have. I hope you get that step. So next, I'll just rearrange this by saying that mean effective pressure is equal to CV all over what? R multiply what? Multiply by what? P1 compression ratio all over what? All over the bracket of what? Compression ratio minus 1 into the bracket of T3 minus T2, close bracket, minus the bracket of T4 minus T1, close bracket. Everything all over what? All over T1. So this is what I have. So from this point, I can substitute my value for T2, my value for T4, and my value for T3. So let's do that right away. So mean effective pressure, M, so with EP, will be equal to CV all over R, multiplying what? Multiplying P1 compression ratio all over what? The bracket of what? Compression ratio minus 1 into what? Now, I have my T3. Of course, my T3 is nothing but what? T1 compression ratio to the power of gamma minus 1 multiplied by alpha. So if I substitute down here, I have T1 compression ratio to the power of gamma minus 1 multiplied by alpha. T3 minus T2. What's my T2? My T2 is T1 compression ratio to the power of gamma minus 1. So my T2 will be equal to T1 compression ratio to the power of what? Of gamma minus 1. This is what I have first. This is minus the bracket. This is minus the bracket of what? Next, what do I have? I have T4 to be equals to what? T4 is equals to T1 alpha minus what is next is my T1 close bracket all over T1. So this is what I have. So this is what I have. Don't forget your bigger bracket here. So next we are going to be wiping this side, even as we simplify further. From here you can see that we have T1 here and we also have T1 here. We have T1 here and we have T1 here. I can bring T1 out from both of the brackets. So let's do that. So my mean effective pressure, so I can factor it alongside T1. So let's do that. Why not we do it that way? I think it will be better that way. So I have T1 out of the bracket. I also have what? Compression ratio to the power of gamma minus 1 out of the bracket. So what will be left will be nothing but what? Alpha minus 1. I hope you get that. So we have alpha minus 1 minus the bracket minus. Now from here, of course, I can only factor out T1, of course. So I have T1 here into what? Alpha minus 1. Everything here is all over T1. Now you can see that we have T1 here. You can also see that we have T1 here. These two terms, I can split them and say what is here divided by T1, what is here also divided by T1. You realize that T1 will go with T1 and T1 will also go with T1. So I can rewrite this by saying what? Mean effective pressure is equal to what? Is equal to CV all over R multiplied by what? P1 compression ratio all over what? All over compression ratio minus 1. What is here is now multiplying the bracket. What is here is multiplying the bracket of compression ratio to the power of gamma minus 1 into what? Alpha minus 1 minus into alpha minus 1. Don't forget, by separating this and dividing it, T1 are all gone. So this is what we have left. So now let's simplify further. Now from here you can see that both the term on this side and the term on this side, alpha minus 1 is common. So we are going to be factoring that out. To factor that out, we are going to be having alpha minus 1 multiplying into rather compression ratio to the power of gamma minus 1 minus 1. So that is what we are going to be having. So let's do that so that you can see for yourself. So we have mean effective pressure to be equals to CV all over R multiplied by P1 compression ratio all over compression ratio minus 1 into the bracket of what? Now this is going to be nothing but what? Alpha minus 1, which is common. What will be having left will be nothing but what? Compression ratio to the power of gamma minus 1 minus 1. So this is what? Compression ratio to the power of gamma minus 1 minus 1. I hope you understand that step perfectly. So now from here we can further derive a relation in order to substitute for CV over R. So let's do that. Now from ideal gas law, we know that Cp minus Cv is equals to R. I hope you remember this from our ideal gas law. We also know that Cp all over what? Our Cp all over Cv is equal to what? Is equals to gamma. I hope you remember that from your basic ideal gas law. Now from here we can decide to factor out Cv. If we factor out Cv from this place, what are we going to get? Factor out Cv. From here we are going to be factoring out Cv here. So if you factor out CV, you are going to have CV into what? The bracket of what? CP all over CV minus 1 close bracket is equals to R. I hope you are not confused with what I just did. I just factor out CV from here. If you multiply through, of course, CV will go with CV. CV multiplied by minus 1 is minus CV. We have what is here back. Now, what do I do next? Of course, I've already established that CP all over CV is equals to what? Is equals to gamma. So I will replace gamma here in this equation. I hope you understand that. So this will be nothing but what? This will be nothing but CP. This is nothing but what? CV into what? Into gamma minus 1. Close the bracket. Everything is equals to R. I hope you are following. Now, what do I do next? I have gamma minus 1 multiplied by CV to be equals to R. What do I do next? Now I can divide both sides by gamma minus 1 close bracket multiplied by R. That's what we are going to do. We are going to be dividing both sides of this equation by the bracket of gamma minus 1 close bracket multiplied by R. Now let me do that so that you can see. So what I'll be doing here, I'll be dividing both sides by what? By the bracket of gamma minus 1 multiplied by R. The bracket of what? Of gamma minus 1 multiplied by R. Now from here, you agree with me that R can go with R, and the bracket of gamma minus 1 will go with the bracket of gamma minus 1. I'll be left with CV all over R to be equals to 1 all over what? The bracket of gamma minus 1. So let's do that. So I have CV all over what? All over R to be equals to 1 all over what? All over gamma minus 1. Of course, in brackets. So now I can substitute the value of CV all over R for CV all over R here in this equation. So let's do that. My mean effective pressure, M subscript EP, will be equal to, in place of CV over R, I have 1 all over the bracket of gamma minus 1. Multiplying what? Multiplying P1 compression ratio all over what? The bracket of compression ratio minus 1. So this is what I have. So I will just rewrite what I have here. The bracket of what? The bracket of what? Alpha minus 1 multiplying what? The bracket of what? Compression ratio to the power of gamma minus 1 minus 1. Now this is what I have here. So lastly, I can further simplify this. I can rewrite this to be what? Mean effective pressure equal to P1 compression ratio all over what? All over the bracket of gamma, bracket of alpha minus 1 into the bracket of what? Compression ratio minus 1. This is multiplying the bracket of what? Alpha minus 1 into what? The bracket of compression ratio to the power of gamma minus 1 close bracket. So this is the mean effective pressure of an Otto cycle, which of course we know that has 4 processes. So I hope you followed this proving carefully and you understood every part of it. If there's any part where you need further clarification, you can let us know in the comment section, and we will love to help. So thank you for watching. Stay tuned because we are going to be having more and more numericals on Otto cycle, where we'll be using this formula to solve many questions. So thank you for watching. Be sure to like, subscribe, and even share this video as it may be helpful to others. Thanks for watching.